This is the last section of Module 7, and it's about trapezoids and kites. So the goal for this one is to apply properties of trapezoids to solve real-world and mathematical problems, apply the properties of trapezoids, use coordinate geometry to find lengths and endpoints of mid-segments, and apply the properties of kites to solve real-world mathematical problems. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So the parallel sides are called the bases. So this base and this base are parallel with each other. They'll never cross. So the non-parallel sides are called legs of a trapezoid. So these ones will end up crossing each other, but the legs you could think of like your legs go up and down. So in a trapezoid, ABCD angle A and B are one pair of base angles, and C and D are the other pair. So here's a pair, and here's a pair. If the legs of a trapezoid are congruent, then it is an isosceles trapezoid. So the theorems for this section are Theorem 7.21. So if a trapezoid is an isosceles, then each pair of base angles is congruent. So for example, if trapezoid FGHJ is an isosceles with bases G and H, so the top sections, then G and H are equal and F and J are equal. Theorem 7.2 says if a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So in that case, then if L and M are equal, then the trapezoid is an isosceles. And then the last one, 7.23, a trapezoid is isosceles if and only if its diagonals are congruent. So if trapezoid QRST is isosceles, then QS equals RT. Likewise, if QS equals RT, then trapezoid QRST is an isosceles. Alright, so if I'm looking at this one, it says the body of a guitar is shown as a trapezoidal prism. The front face of the guitar is an isosceles trapezoid. So they give me the measurement. So I need to prove that x equals 11. So if I go back to these theorems, for an isosceles trapezoid, it says if a trapezoid is an isosceles, then each pair of base angles is congruent. So the bases would be congruent, so they're equal. So if I go back here, I can do AD is equal to BC. So let's try. So AD is 4x plus 5 equals, and then BC is 5x minus 6. So I'm going to add 6 to both sides first. So over here I get 4x plus 11 equals 5x, and those 6's cancel. Then I'm going to subtract 4 from both sides. Those cancel, I get 11 equals x. So now the next one, so we have find at the measure of A if the measure of C is 72. So because ABCD is an isosceles trapezoid, C and D are congruent base angles. So the measure of C is equal to, so we know it tells me it's right in this problem that C and D are equal to each other. So angle C equals angle D, and they told me up here that C is 72, so they both have to be 72. Then it says because ABCD is a trapezoid, AB is equal to CD. So angle A and angle D will add up to 180. So I don't know what angle A is, but I know what angle D is. So D is 72. And now I can solve for my problem. So I'm going to set up with A plus 72 equals 180. So I will subtract 72 from both sides. So A equals, I get 180 minus 72 equals 108. So the measure of A is 108. Now part C, to find the perimeter of the front of the face, this is the part that you will use when you're older. You will find perimeter of things. So you would add those two bases and the two legs all together. So they gave me all of these. So if I go back up here, remember how they gave us each of the side lengths? So those are all right here. They match up with the colors. So then I'm just going to substitute. Well, I could combine my like terms first. So let's do that. So we know 3x plus 5x is 8x, plus 3x is 11x, plus 4x is 15x. Then I have negative 2 minus 6 is negative 8, plus 9 is 1, plus 5 is 6. So we have plus 6. So then I'm going to plug in. We found previously that x equaled 11. So then I'm just going to plug in and see what I get. So I'm going to do 15 times 11 plus 6. So my perimeter of my guitar would be 171. All right, so then the next section of this one is finding the mid segments. So we know mid means middle. So looking at this trapezoid, that mid is at U to R. So by the trapezoid mid-segment theorem, UR is equal to 1/2 of the sum of PQ and TS. So sum means I add, so I can add together my PQ, so my top base and my bottom base, and then divide by 2. So we're not gonna use that over here, we're just going to do this. So we're gonna start with 11 plus 18 equals 29. And then I'm going to divide that by 2. So 29 divided by 2 gives me 14.5. So the mid here would be 14.5. And looking at it, you can make sure that it makes sense. So the top one is 11, the bottom one is 18, so it has to be between those two numbers. The next part is kites. So a kite is a convex quadrilateral with exactly 2 distinct pairs of adjacent congruent sides. Unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. So theorem 7.25 says if a quadrilateral is a kite, then its diagonals are perpendicular. So remember, perpendicular means that they cross and they make 90-degree angles. And theorem 7.26 says if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So let's look at one. So it says find angle measures in kites. So if KLM is a kite, find the measure of N. So because a kite can only have one pair of opposite congruent angles, we know that K and M already don't equal each other. So we know that ultimately N and L are going to equal each other. So with the kite, when I add everything up inside of it, it will equal 360 degrees. Because I could cut this in half and it gives me 2 triangles. And remember, one triangle always equals 180. So I can add all 4 of those angles and it would equal 360 degrees. So I'm going to plug in what I know. So they already plugged in for M, and I know K as well. So K equals 71. So then when I combine my like terms, 71 plus 52 equals 123. So then I subtract my 360 from my 123. and I get 237, and then I divide by 2, and I get 118.5. So N would equal 118.5, and L would equal 118.5. And then finally, find lengths in kites. So quadrilateral ABCD is a kite. So part A wants us to find A to D. So because the diagonals of a kite are perpendicular, we know that this triangle over here, this corner would be 90 degrees. So because it's 90 degrees, we know that we can use the Pythagorean theorem. So if I'm looking, remember my Pythagorean theorem is I'm going to do the squared like this. A squared plus B squared equals C squared. So I'm going to plug in. So I know that this part, because it's across from my right angle, will be C. So they've actually given me the A and the B. So it's going to be 12 times 12 plus 24 times 24 equals C squared. So let's do that. So we have 12 times 12 times 24 times 24. So I get 82,944. And then I'm going to take the square root of that, and I get 288. And that's it. So go ahead, and now you can go make your lesson.